Okay, so atong idulit. Okay, welcome back mga palagingging. Lah, wow. Welcome back to my YT channel. Ooh. Ooh. Welcome back to my YT channel. This is again your content creator and social media influencer, Junjun Grisero. And now, our topic for today is related to chemical reaction rates under the study of chemical kinetics or chemical reaction engineering. So if we need to study about chemical reaction engineering or the reaction kinetics or the chemical kinetics, then we need to understand the reaction mechanism, the rate determining step, and the initial rate methods. All we have to do is to understand the concept of the chemical reaction rates, chemical reaction constants, and also the overall reaction of different orders, and also the summation and the total of our overall reaction order. Okay, I will be able to give you an example here in which before when I was in high school, okay, I cannot understand easily for this. Okay, then I kept on striving my best, then exert efforts a lot. Then when I joined the chemistry quiz bowl, so I didn't expect to be the champion at the time. So I just love to do it like that. It's just like playing games, things like that. Because I love really science. It's natural for me to remember things like that. So this will be an advantage for me if I will also memorize the moment it will be written in the board by our teachers. So I can easily grasp in English. I can really, even though I will not write in the notebook, the thoughts. So, okay, so it's easy for me to remember even though I will not write. But if there are difficult and complex topics, and at the time also I could be able to write in a notebook. Now, it would be a great help for my parents because they don't buy too much notebooks. Okay, because if I will keep on writing, maybe I have 10 notebooks, 12 notebooks. So in that way, I can also save things like that because there are things and writing on the boards, whiteboard or the blackboards in which I don't write anymore. It will just come to my mind, you know, things like that. Okay, then this is really an interesting topic because sometimes you will be wondering what's going to be happening of our chemical reaction rate, if it's going to be fast or slow. Okay, so what going to be our chemical reaction goes like that. Okay. So things like that. So since chemical reaction engineering or chemical kinetics is the study of reaction rates and then how fast our chemical reaction goes, then it's not only how fast, but it's also how fast and slow that our chemical reaction goes. Okay, since we are really trying to determine, or let's say we are expecting and optimize, because that would identify that we have really a very active, spontaneous, and vigorous chemical reaction. So let's say I have here ammonia. Oh wow, ammonia is a ligand, meaning to say Lewis base. Okay, it's really can be acting like an acid sometimes, like acidic, and sometimes slightly basic. Okay, it depends on what theories you will be able to use. If you use Arrhenius theory, Bronsted-Lowry acid and base, and Lewis acid and base, right? Okay, things like that. Now, ammonia will decompose into, the first thing to do, we need to put here a small triangle and an arrow going there. This small triangle meaning delta, then this is heat, okay, things like that, okay. But some books don't really show this heat anymore because it's understood that you cannot decompose ammonia alone by putting that in your table, in your kitchen. If you put ammonia in your kitchen and you don't do anything, it will not vaporize, things like, unless you will bring that ammonia sample outside your room and it will be vaporized under the heat of the sun. Then you do something, right? Because you carry that and then you put that outside in the room, then of course there will be an exposure to the heat of the sun, then evaporation takes place, right? The conversion of liquid into water vapor. But if you don't do that, you will keep that ammonia sample inside your kitchen or whatever inside your room, then it will never be vaporized. Things like that, right? Now, that's why I put an emphasized here the delta heat. But obviously, it doesn't mean all the time to put like that. Okay, I'm just emphasizing that one. Okay, so maybe you are not aware that there will be no heat applied or whatever because the books are not putting also delta heat anymore. You get the point? Imagine it will not decompose easily. Okay, you get the point without the application of external energy or whatever physical task or chemical process that you will be able to do with your sample. You get the point? Okay. Now, I will erase the delta heat because it's understood. So this is a type of chemical reaction which is decomposition. Okay, this is very popular in the optimization of the yielding of appropriate, desired product of fertilizers, like that in fertilizers industry. So this is discovered by our scientist known as Mr. Haber. So this is known Haber process. Okay, so if the exam will say, what is a Haber process? You will just simply say, oh, it's the reaction of hydrogen gas and nitrogen gas to produce ammonia. Because ammonia will be our raw materials in fertilizers industry, like that. So they will be applying this concept in fertilizers industry, those industries that will produce fertilizers in the market or globally or locally, whatever. Okay, now we have here ammonia, right? Okay, so this is gonna be nitrogen gas plus hydrogen gas. Now balance the chemical equation. Okay, so we have two nitrogen, if we put two here. I will use trial and error method because it looks like the number of atoms are very minimum, like that. So if it goes beyond 4, 5, like that, 3, whatever, then I will be able to use the algebraic expression of balancing the equation. But in here, it's just trial and error method because 2 only, 1 only, or nothing, right? It's easy to manipulate, right? I have to put 2 beside nitrogen. Okay. Then nitrogen 2, 2 nitrogen here, balance. And then hydrogen, 6. Then you have to put 3. 3 times 2 is equals to 6. So these are the most, typical method that our students use, right, in our chemistry class. But beware of this technique because you will be confused somewhere along the way if your chemical reaction will involve fraction. Okay, get the point? So meaning the number of atoms are greater or higher. For example, if you try to decompose a gasoline, let's say, and you put the gasoline in your internal combustion engine. So it's gonna be like a chemical energy conversion from chemical energy into mechanical energy, right? Things like that. So we have gasoline. The formula of gasoline is 8 atoms of carbon and 18 atoms of hydrogen. So the moment your car will run, it needs 8 atoms of carbon. Okay, then you will be able to undergo complete combustion, which result into carbon dioxide and water, things like that. So take a look with your number of atoms of hydrogen. Could you balance that easily? Compare to our decomposition of ammonia, which have only a higher, 3 is the maximum only number of atoms or moles, things like that. Of course, it's not easy to manipulate that 18 atoms of hydrogen in your gasoline inside your combustion engine. You get the point? Things like that. Okay, so you need to assume that you need to have a complete combustion, or else if the activity or the process inside the combustion engine is not perfect, there's a lot of leakages, then you will be producing carbon monoxide. Okay, that is deadly gas. Okay, so things like, and then your car also will not be able to run if there will be complete combustion in the first place. You get the point? So if there are any signs of leakages of the fuel, it's understood that something technical problems or whatever problem inside your internal combustion engine, then you have to check up. You will open the hood and call for mechanic to do that, things like that. But the root cause is only the combustion process. Get the point? Things like that. Now going back to ammonia. Okay. Now, so this is all about rate. Okay. Rate sa pag-ibig ni Junjun. Okay, rate. Okay, guys. Capital R, capital A, capital T, capital E. Rate. Okay. When you speak about rate, so one thing in common in our minds are really the unit of time in the denominator. let's say, per second, per minute, per hour, per year, things like that. Just like you borrow money from the bank, then there must be an interest rate. So according to annual, monthly, so things like that. So this is the first thing to understand about the word rate. There's time or period or duration in this terminology. So one thing is missing na lang because we're talking of chemical reaction. You need to say like, so, okay, delta change like that. Then if you can see a bracket concentrations, talking about concentrations, okay? So we have delta change of, let's say, any of these three quantities here, for example, N2, okay, over delta time, as I told you a while ago. So I would say, change in the concentration of nitrogen gas per or over the change of the time. Things like your time, if you want second, then you can do. If you want minute, then you can do. Okay, things like that. No? Okay. Now another delta change in the concentration of hydrogen gas. Okay, over delta T, same pattern, also the ammonia. Okay, delta change of ammonia, okay, like that, over the change in time, like that, okay? So this is your individual rate, reaction rate of the specific elemental constituents and also compound. Ammonia is compound, both nitrogen and hydrogen are elements. That's why I'm saying elemental constituents. Okay, to make it vogacious. Because actually it's just elements, but to make it sound, expensive, I would say elemental constituents. Okay, you get the point? Things like that. So we have here N2, H2, okay, and we have the ammonia. Okay, you get the point. Now, basic concept. In your reactant, okay, the concentration, let's say 0.5 molar, then if the chemical reaction proceeds, let's say your activation energy has been established, and then it will proceed the chemical reaction, then your state of dynamic equilibrium is very ready, and it will go to perfection, then your 0.5 molar will decrease here, your ammonia. It will be used up to be shared with your nitrogen gas and hydrogen gas. Nitrogen gas and hydrogen gas concentrations will normally increase. You get the point? So things like that, no? Okay, for example, if 0.1 molar, it will rise to something. Okay, things like that. Example only for the purpose of discussion. Okay, things like. So now, your NH3 will be delta change of ammonia delta T negative. Okay, and your concentration will be, meaning to say it's consumed, it's used up, it's disappearing, it's vanished, it's being gradually lost, things like that. Okay, it depends on the synonyms that you will be able to use. As long as it reduced, decreased, used up, utilized, like that, no? Disappeared. You will just use the word rate. So, rate of disappearance, rate of consumption, okay, things like that, no? Rate of reduction. So, there's a lot. So, don't confuse with the terminology. The terminology is just terminology. Focus on the concept. Okay, get the point, things like that. Negative sign of your rate here would mean only not the magnitude, would mean only the reduction, minimization, or the reducing of your concentration. Because once you reduce, that's negative in your part. For example, if I will buy, I have a salary of $10,000, and if I will buy, let's say, a microwave oven costs $2,000, then I am deducting it from my original salary. So I will be in the negative side because there's no addition. So I will be in terms of negative because somebody deducted to it because I buy a microwave or things like that, no? The concept will be like that. Okay, now it's gonna be like that. Now, we need to determine the individual reaction rate. And then later on, we want to determine the overall reaction rate with respect to individual element and also the compound. How can we do that? For example, if we try to assume, but actually this is not really assume, this is really standard. Okay, based on what I understand and research a lot in my college days and even up to now, things like that, no? So if this is the case, guys, we let our molar per second. Molar per second is the rate. That's what I told you. Because this is concentration and it is second. So meaning to say, guys, you need to have 0.01. Let's say your rate of your delta N to delta T, like that, no? Okay, things like that. Okay. Now, if I have 0.01 molar per second, how much my delta H to delta T for that? Okay. So other teachers will say it will just like looking at the stoichiometric relationship that there are 3 moles of H2 and they will just multiply directly by 3, right? I will multiply 0.01 by 3 because of this, like that, and then like that. So I don't want to use that. Let's go with the math rule because it looks like tamban-tamban if we do that. Times 3, times 2, times 3, like that. So we need to go to the formal way of computation. Okay, but actually it's just okay also. 0.01 times 3 is equal to 0.03 and then ammonia 0.02 because you are starting with 1, right? That's only estimating, but you know there's problem in this kind of discussion if the problem will change. Especially if the rate is higher and it's not anymore like this. You get the point? So, I will teach you. Use the stoichiometric relationship and use the conversion method. You will say, so, if we have the nitrogen gas molar per second, you will use this. You determine the change of concentration of hydrogen gas with respect to time in this manner. 0.01 molar per second times, okay. How many hydrogen here? You got 3 things like that. So, you need to say 1 mole, okay, like that, no? Okay, okay, since your reference will be N2, you see, 1 mole N2, like that, is equals to 3 moles hydrogen gas. Okay, 3 divided by 1 is 3, that's why 0.01 times 3. You get the point? Actually, that's the pinaghugutan why it will become 0.03 directly. The teachers will say it will be multiplied by 3 because like this, like this. Okay, but that is not the way the detailed discussion. Okay, 0.03. Okay, so dito ray lahat ba manas la NH3 2 times 2 din ang 0.01 di i-compute ba nga makasabot ang mga estudyante di nagikan mo kalit ra multiply way hinungdan. You get the point, things like that. Okay, so you say 2 moles of ammonia. Kasi nagito guys ha, okay, ammonia. So change of concentration of NH3 over delta T. So I have 0.01 originally. 0.01, okay, we use our change of calculation. That's why we always put that in our first stage of our calculation. That's the purpose of basis calculation. You will use that all the time as your starting point in your calculation. So 0.01 molar per second, okay. Nitrogen again, see, 1 mole. And then ammonia 2. So 0.01 times 2 is equal to 0.02. That's why the teacher will say 0.02 directly. Okay? 0.02 directly. And we will say multiply by 2. Actually, it's not like that the way it is being explained. Really. And then if the like this, times 3. Like that, times 2. So me also, I'm found difficulty in that before. So use the good calculation, in terms of your stoichiometric relationship. Okay, here. You have the basis how to calculate it. It's not only like times 3, times 2, times 3 because you have like this. No, it's not good, Okay, that's what I discovered for some chemistry teachers. Okay, get the point? Things like that. Okay, now, we have the 0.01, okay, molar per second of concentration of nitrogen with respect to time. We have 0.03 molar per second with respect to hydrogen. We have 0.02 molar per second with respect to ammonia. Now, this is individual reaction rate. How can we compute the overall the individual reaction rate based on the overall reaction. So this is only individual. Okay, how to compute the individual reaction rate based on the overall reaction order? Just like, for example, I have one cake like that, no? I have one cake, and then I have two brothers and two sisters. For example, okay, let's say two sisters and one brother and me. So we have four in the family. So I will divide the cake into four. Okay. So if you try to have an analogy with our explanation here, the individual reaction rate is only the budget of each person taken away from the whole piece of a cake. This one, we cut this one. So this one, the N2. We cut this one. So si H2, me, Junjun, I have to get this one for me. My sister also will get ammonia, will get like that. But in terms of overall reaction order, in terms of the whole package, you need to say 1/4 for Junjun, 1/4 for his brother, 1/4 for his sister, and other sister also. So 4/4. So 4/4 is equal to the one whole cake. So, the same like that also principle in our chemical reaction engineering or in this topic. So, we will say, since we are now the basis of our calculation in N2, so we're gonna say the delta N2, delta T in the overall reaction order will be, okay, things like that. Okay, delta T. Now, use your basis of calculation, which is this one. For N2. So for N2, say 0.01 molar per second. Ganon. Diba? Get the point, mga palangga kong hitan. Now, since you are now 0.01 molar for N2, what is the N2 there? Okay. Times, okay, N2, 1. Because 1 mole of N2 in the reaction and also 1 in the overall reaction. The other, only the nitrogens. It will become 0.01. The same thing. Okay, nothing changed for N2. Okay? Because in the reaction, N2 has only 1. Then obviously, the 0.01 molar per second individual reaction rate will be just the same also with the individual reaction rate based on the overall reaction. Now, we go to the delta H2 over delta T. So, delta H2 over delta T. So, use this 0.03. Okay, 0.03 molar per second times H2. How much N2? See, 3. So, 3 moles. Okay, then, what is your N2? You always use the N2 at the top because N2 again is your basis of calculation. You need to put that every time as your basis. Okay, so 1 mole of N2. Okay, this one. 0.02 divided by 3. Okay, namuna siyang 1/3. Okay, get the point? So, really guys, okay, so, I'm just wondering, why 1/3? Like that, this is really how it being processed. Okay, so actually, so 0.03 divided by 3, see, it will be equal to 1. Okay, 0.3 divided by 3. Like that. So, 0.01. So, it will be equal to 0.01 in which this is the basis of a calculation we use all the time. Now, we go to delta H3. Okay? So, meaning to say, it will be constant. Always 0.01 when you do the individual reaction rate. Okay? But the overall thing, this will be the how to compute, okay, delta T, and then we have 0.02, okay, 0.02 molar per second ammonia, okay, okay, 2, put the 2 here, ammonia, and 1 also nitrogen at the top because it's our basis, 1/2. That's why 0.02 divided by 2 will be still 1.01. Okay, see, divided by 2, 0.01 molar per second. All because we let our delta N2 concentration as our basis of calculation. So all will be 0.01, 0.01, 0.01, 0.01 in the overall reaction order with respect to each element and compound. But when you say reaction rate individually, this is the answer. 0.01 molar per second, 0.03 molar per second, 0.02 molar per second. It looks like confusing, right? Okay. So again, when you mean of individual reaction rate, meaning you don't focus to the entire overall reaction. You only take that as a piece by piece. Okay. Now if you talk here, your overall reaction order, you will say individual reaction order each divided by or out from the overall reaction rate in the whole process in your chemical reaction. Just what I discussed to you regarding the cake, right? The whole cake that we divide by my brothers and sisters like that. Okay? A portion like that, ganon. Okay? You got the point? Okay, things like that. That's why. Okay, that's why. When we see on the some vloggers, science vloggers, and some teachers will go directly like this. They will say like that immediately. Delta, sabi siya guys? Wait ha. Whiteboard ba siya? Okay. Delta concentration of N2 over delta T. They will say immediately like this, 1/2. Negative 1/2. And then delta N2, delta T, like that, positive 1/2. And then, hibo ka mo kulit na nag 1/2, kalito nag 1/3, bato siya ang solution gamiton. Wa man na-emphasize sa teachers. You get the point? So 1/3, okay, delta H2, delta T, mo na 1/3 siya. You get the point? Di ba, mukalit lang, inikatanaw mo sa libro. So you will wonder, why it become 1/3? Why it become 1/2? So that's the reason why, because we have the basis of calculation. Any of them, you can choose ammonia, nitrogen, hydrogen gas. Your basis of calculation will be always be like 0.01 molar per second. Okay, get the point? Okay, so things like that. So this is the magic, no? Okay, so because we are not taught about this 0.01. You got the point? So things like that. But if you want also another basis of calculation, make sure that it will be having the 1/3, the 1/2, like that. You got the point? Well, I tell you to be, okay, negative 1 natin, say ammonia. This is, basis of calculation of N2, right? So, times, like that. So you say, ammonia. Nagra itong ammonia ay. Okay. So, ammonia, di ba? 2. Then 1 ang nitrogen. Di ba 1/2? So, wala na 1/2 ang ammonia. Okay, get the point? Dili, ammonia ni siya. Muna siya na 100. So, 1/2. The negative because rate of the disappearance, and it will become less during the chemical reaction. How about nitrogen also? Nitrogen, no need, because this is our basis of calculation, nitrogen gas. So, why it become 1/3? So, because you use the basis of calculation of 0.01 molar per second N2, then your N2 will be used as your reference. Then we'll like that. Okay, hydrogen gas, 3. Then ang N2, 1. That's why 1/3 siya. You get the point? Nakakaloka, ba? So, mo na siya ang hitabo. Okay? So, that's why it will become negative 1/2, positive 1/2, positive 1/3. Okay? You get the point? Okay, but this is just more on concepts in our problem solving. This is like this all the time, huh? Okay, you get the point. So this is only, we need to remember if the number of us will change to something, and then you need to apply this over and over again. Because sometimes it will say, what is the concentration of hydrogen gas if our initial concentration of ammonia will be 0.2, like that? It looks like very, very strange. Okay? So, in that way, you remember, okay, like that. Things like that. Okay? Get the point? It's the same thing because you give the reaction rate of ammonia. It's no longer the give, but it's just the same process on how you do it. You get the point? Things like that. Any questions so far for this? Nothing, right? Okay. You get the point? So, mo na siya ang atong timanan sa atong mga rate of chemical reaction. Okay, class? Okay. Welcome to our chemical reaction topic of, let's say, actually this is just, this is not more on the chemical engineering style of reaction rate. Okay, but it's just the same, the basic concepts will be in a complex chemical reaction, right? Or problem solving, chariot. Okay, now I'll give you an example for this, no? Char. Wait mga palagingging. Jun did an experiments, trials 1, 2, 3. Okay, what's that? Ako naman siyang kuhan, guys. Okay. He went to the microscaling laboratory and get samples of nitric oxide and chlorine. Okay, he added the two, okay, and produced this nitrooxychloride compound. First, initial concentration of NO, 0.1, second, 0.1, third, 0.2. The concentration of chlorine is 0.1, 0.2, 0.2. And the initial rates of each trial, trial 1, 0.18, trial 2, 0.36, and trial 3, 1.44. Okay, so what is the reaction order with respect to each individual reactant? And what is the overall reaction order? What is the rate low or rate expression? And what is the chemical reaction rate constant? Okay, things like that. So it looks like confusing the terminology, right? Let me explain. Okay, so if you mean rate constant, this is actually the same as chemical reaction rate constant. Just dropping the chemical reaction because we are studying chemical reaction. Okay, but if you want to be precise, we need to say chemical reaction rate constant because there's a lot of constants regarding to rate. It could be in terms of money, in terms of velocity, in terms of speed or whatever, acceleration, like that, no? Or effective interest rate, things like that, or whatever. Now, since we are dealing the present topic, we don't have to put everything. But you should not forget that that is really the easiest way of saying it. Okay, chemical reaction rate constant or rate constant. Now, if I will say rate law, okay, rate law is just the same as saying chemical reaction rate law. And this is also the same as saying rate expression. Okay, so expression can be used interchangeably with the word law. Sometimes in different textbooks, they will just say rate expression, not the law, but it's just the same. So rate expression will be just equal to chemical reaction rate expression. Okay, now we go to the order. Okay, action order. Okay, so this reaction order means chemical reaction order. Dropping chemical because it's understood. But some books also dropping everything, only put order. Okay, but it depends now what is your reference you are trying to find out in your order. Could it be in the reactant, in the product, things like that. Okay, now we have also overall reaction order. Now this would mean completely, to be precise and highly technical, this is overall chemical reaction order. But it's too long, that's why our teachers or the books dropping that only to overall order or overall reaction order or overall order or total order. Because it's overall meaning it's the sum of all the order. You get the point? So total order or total order or the summary or the total or overall, things like that. Okay? Because sometimes also, in the examination, they will list what is the total order of the reaction. And then you are always hearing your teachers to speak overall. And then you will never apply that anymore because it's not the same letters. You get the point? There are a lot of students, I found it. There's a lot of students like this, dependent on the term to term. If the teachers will discuss this term, and then if it will never use that term, the same term in the problem solving, they will never use that as the same concept. So, overall meaning total, obviously. Okay, get the point? Or the sum. Okay, things like that. You get the point? Okay, you don't need to be dependent all the time with the same words, huh? Okay, get the point. Things like that. Okay. So, for example, what is the chemical reaction rate expression? Sanay kay ka sa ritlo-ritlo. Sometimes malibog ka. It's not the same, man. Okay, low ba ya? Expression. Not the same spelling. Okay, and at the same time, when you express, it's far from law. Law talks about legislation. Okay, law talks about the protocol to follow, the policy to follow, like that, no? The procedure, the methodology, the Republic Act, okay, everything. You get the point? So expression is different because expression talks about how you express yourself, like that. The meaning is entirely different. Be careful, but it's just the same. Expressing yourself to something. Oh, Junjun has a good expression when he delivers his discussion with too much expression coming from his mouth. Things like that, right? But in here, rate flow and rate expression is just the same. Okay. You get the point? Okay, so don't focus too much on the literal. Okay, get the point thing, a word for word, na paabot siya kaya man ni-apply dito, wala dito magamit ang formula para ang tagid ato, naglahi lang ang term. Ay nako. Get the point? Things like that. What is the rate? What is the solubility of the concentration with the zero order? Kaya ang topic dito, ang maestra, sige magyaw-yaw concentration, wa siya kibaw, solubility and concentration are just the same. You get the point? Things like that. That's why in our general chemistry, the introduction part of general chemistry, we have four factors that affect the concentration, or four factors that affect the solubility. A, the nature of solute, the nature of solvent, temperature, pressure, volume, mga anak, no? And sometimes adding a catalyst or inhibitor. Enumeration, right? So in our chemistry, ganun katag enumeration. What are the factors that affect the concentration? Muti mong ibang answer, temperature, pressure, nature of solute and solvent, volume, adding a catalyst, an inhibitor, things like that. Okay, so we should be, what do you call this one? Versatile in our understanding of the terminology and the wordings in our study of chemistry. Okay, that's the point. Another example also, the extrinsic property. Extrinsic property. Okay, I cannot forget this kind of problem because this is the last question during my quiz ball in our school, in Naga National High School. So this is the last question that made me win. This they give the, okay, they said, what, blank is the blah 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 blah, A, extrinsic power. But actually, they don't put what is that. This is a property like temperature, blah blah blah, what, and then I answered extrinsic property, it's correct. And that's the last question. Okay? Things like that. I can never forget that for the rest of my life. You get the point? Things like that. Okay. So, extrinsic property. Okay, what do you mean by this? It's just the same as saying extensive property. You get the point? Okay. Okay. Extensive property. Uy guys, wala pa ako sa college ani ha kay maawaw ko, okay? I'm only sharing this winning moment in my vlog because I have the right to do it because this is my channel. I have the like that. And in fact, I don't tell my parents and my family that I won chemistry quiz bowl in our school. Really. I am not really saying anything. It's only when I'm working now in my vlog when I have the social media account. And I keep that to myself. Okay, but to those who know it, they know already. Of course, my classmates, my batchmates. But other than that, I never say anything. Because it's not good also to say, right? Okay, without any reason. Me, I have the reason only. I have the account. I have to inspire the other people. And that's why I will say, I'm the champion of the chemistry quiz book because I want you to be challenged, to inspire yourselves also, things like that. No? Na ako'y rason. Kasi you will just tell that immediately. It looks like arrogant also when you, champion di ako sa una sa chemistry. Wala ba nangutana? Charot. You got the point? Okay, things like that. So here, I can say, because there's a reason for me to say, okay, to inspire you. Then I can also tell that I'm really qualified to do chemistry vlogs, right? Or science vlogs. Okay, because I have the records, okay, and accomplishments. And my course also is related to science. Because the point, so things like that. Diba? Okay, gusto na sa kanya, mag-vlog-vlog ka nga, layo ka sa kaayo. You get the point, things like that. Okay. So muna siya, ang extrinsic and extensive property are just the same. Means, these are the properties of matter that depends on the amount of matter, the size of the sample. Okay. Things like, for example, the temperature, the pressure, mga ganun, no? The length, the width, the area, the weight, the mass, the volume. Okay. Then the intrinsic property and the intensive property of matter is the reverse. Okay, it doesn't depend on the amount of substance in the sample of the substance and the amount of matter. Okay, so these are density. Okay, okay, we have force, boiling point, melting point, viscosity, okay, surface tension, specific gravity, things like that, no? Okay, things like that. But you know guys, energy is under extrinsic property and extensive property. All types of energy, for example, heat energy, okay, chemical energy, kinetic energy, potential energy, okay, pneumatic energy, hydraulic energy, hydro energy, like that. There's so many energies, right? You get the point? Then electrical energy. Okay, you get the point. Mechanical energy. Okay, so there's a lot of energies under extrinsic and extensive property. Take note. Okay, so meaning to say when heat, if you try to categorize heat, heat is under extrinsic and extensive property. Get the point? Get the point? Ganun siya mga palangga. Ha? Okay. So, during the memorization, just put that energy only as an example of like that. So, usually sa mga first law of thermodynamics, right? Law of conservation of energy, right? Energy can neither be created nor can be destroyed, but it can only be transformed to various forms of energy. That's the first law of thermodynamics. Get the point? So remember that, attach that in the concept of extrinsic property and extensive property. Okay? Kaya somebody will say, na ako'y friend, somebody will say, so wala ta ko makuha chemical engineering, diba? Dapat sa'yo, BS chemistry. Kaya naka-observe man. Chemical engineering kay wa may BS chemistry sa CIT. Because the moment kung naa pa lang dun siya, then I will take BS chemistry like that. Okay, things like. But again, it will not be pushed. He wanted me to came from the eye. Things like that. Just because of him. I really wanted to become not really I didn't like at first because as I told you, I'm very consistent. I'm not really good in math. Right? So this is just only to suffice the requirement of my family, my sister, my brother, because they wanted me to become an engineer, have a title in my name, things like that. Okay, but this is just only a fancy and a worldly. I think it's only just because of they are proud like that. But if you, that is not really the important, right? For me, huh? Okay, at the time. But you know, since I don't have any other choices, then I have to take closer things like that to my academic presidential scholarship. Okay, I want to become a broadcast journalist. They will cry. You don't like. sure. But that is my first love, to become a broadcast journalist before the engineering thing. Okay? Since my scholarship has no offer of this mass communication, then all our engineering and sciences courses reflected in the scholarship slot. Diba? May scholarship slot and you will apply that one. There's no, you will take that in a checkbox kung sa'yo gusto ni mo course. Wala man siya kuan, may broadcast journalism, mas kung wala, kung na bakit ko mag-study o I want to become a renowned broadcast journalist because that is really my dream. I want to be in the media, things like talking and communicating the public, things like that, because I love writing, I love speaking, and I love English that much. If I love science, I love more English as much as I could. Things like that. But it was really disappeared, then it was lost. And I already starting to study engineering. Okay, you got the point? And then I love to study math na, even though I don't like at first. You get the point? Okay. Things like that. My grades in math are not too high, but pasok pa rin siya sa mga sa honor student, like that, okay? But what I'm trying to emphasize, dili siya superior ba? Okay, get the point, things like, okay, di ba? What you kasuhay na ma-best math ko? Okay, things like that. Sige lang ko kalang, mura ko kasuya, kaya what you kakuha ng mga best in math. You get the point, things like that. Kasi ito siya kumaig math, alam mo, pupukso na ako. Diba? Ganun siya. Okay. Things like that. But it is true really. You don't have to be brilliant in math and to be very good in math to become engineer. Okay? Trust me. Okay? Because I'm not good in math. Okay? I'm just trying my best to study hard. Okay? Ang parents lang, sayo sa if their sons and daughters, they want to become an engineer, right? But since they are not really good in math, they see their grades and they will discourage their sons and daughters. You get the point? But they love to become an engineer. So you don't have to stop what they like because they will just start to love it the moment they will go there in the first day of their school. They will suggest course according to their sons and daughters in which they don't love. And since like me also, I'm loyal to my parents. So most of the children are loyal to their parents because they set them as the paradigm, an example, the success obtained by their parents, and it will be radiated to them in the future. That's why they cannot complain. But in the first place, they don't love that course. You got the point? So they don't have choice because they will be the one to educate them. And then, because my father is very successful, I want to be also like them. But deep inside, they don't like that course. With the moment your sons and daughters will say, this is the course I want, give them the chance to study that because they love it. You get the point? Do not decide what they like because it will suffer. They will keep on changing course if you don't like, they don't love the course that the parents wanted them to take. Okay, you get the point? And then sons and daughters also, don't be also influenced by your parents of what you like. Because it will affect really if you don't like, na Diyos ko, di mo ganahan magtuon sa di mo ganahan. You get the point? Things like that. Just like our safety officer before, he liked to become an engineer, but he is a nurse, certified and licensed nurse. He's a safety officer. He don't want really to work as a nurse. You get the point? And every time we talk in our departments, he loves to listen to me like that about math, about chemistry, like that, science, engineering topics, because he craved for that because he loved to become an engineer before when he was young. But he don't have choice anymore. He already a nurse. Things like that, no? Because the sister of his mother want to educate him because after that he will be going to the Europe and America, like a plan in the future, but then instead he don't like the things like that. No, it's not good. Later na lang nang kung sa plano sa inyo, after na gusto dyan na makuha dyan ba ka na, iya dyan gusto. Okay, you get the point sa bata. Because if you want to become a doctor or lawyer, just leave it. Kasi matter ang finances, no? Finances, matter ang finances, right? Hindi ka ka-afford. Things like that, no? So, i-adjust na lang po, i-explain sa bata, things like that, that digital they will study more to become what they want really in life. Get the point? They will proceed to become a doctor after the preparatory course. They will proceed to become a lawyer if you take pol sci. If you take something blah blah blah, they proceed to something like this. Di ba? Gano'n eh. Ay mo pabot-buot sa gusto dito eh. Nakakaloka. Okay? Pero ako ba guys, musunod ko sa akong parents. I'm very loyal to my parents. This is just talking because I feel what it feels to be in that situation. Ganon. Because when I graduated in chemical engineering, I was licensed chemical engineer at the time. I want to teach. Really, I submitted application in our school to become a teacher. Okay, things like that. And then I submitted everything like that, blah, blah, blah. When I reported to my parents, they discouraged me. Said, don't do that because your course that is specialized in blah, blah, blah. Just try to experience your course like that. And I followed them. Things like that. And then at that time, when I follow them, I keep on enjoying now in my field like that. For example, okay, then I forgot to be back on what I love. You get the point? Because I started already going in different industries. I forgot to go back with my first love. Okay, to teach like that, to become a mentor, blah blah blah, so and so. You get the point? Ganun, wala siya na push through. That's why I love to vlog because at least, you get the point. So, magamit siya po na ako, but not in the formal way, but at least, nadyo po katiting na, a resemblance of being an educator or mentor in, or a vlogger in social media. Things like, you get the point? Ganon. Okay, but I still don't lose hope. Okay, so I really need to go farther. Okay, I really want to be in the academy someday. Okay, but I don't know. It's up to God that will guide me. I really love to. In fact, I really love to make my own books, like authored by myself. Book created by me with regards to these topics, blah blah blah, so also. And it was not really pushed through. Okay. Because I'm not keep on studying, no? Our parents are not rich. Maybe if I am belonging to the rich family, I keep on studying after graduation. I studied the master of these. After this, I will study the PhD, so there's no problem. But since we are struggling for money, of course, we need to work immediately. You get the point? But if I am a son of a rich family, maybe I am a doctor already, and blah, blah, blah. Sure, 100%, because I love really to study. You get the point? And we are not struggling for money because we have enough. Di ba? If we try to work, we need to have money, right? To sustain the family. Then if your parents are rich already, then why you work immediately? Things like that, just because of your own family, like that, to establish your own family. Okay? But in my case before, I don't really plan to marry. Okay? That's why I keep on studying like that. Okay? Even up to now. Even I'm not studying in a university. I'm studying in my personal here in every Friday and Saturday. And documentary, science, biochemistry, everything about academics, science, health information, blah blah blah, so on so. You get the point? Ganon. Then if I will be tired, I will sing. Okay, do my reels like that's only like that. Okay, I don't watch movie. I don't really watch movies. Okay, things like that. Ever since I don't really watch movies. Okay, I will only watch movies in the Philippines with my niece, nephews, like that in the family. But personally, I don't prefer to watch full movies. You get the point? Only short movies like 15 minutes, 20 minutes, like that. But more on the documentary. I love documentary with regards to the general information, like that. I really love, no? So, ganun siya ang may tagbo. Okay? Nadyo ko yung sariling mundo. Okay, got the point? Ganon siya. Okay, guys. So, thank you so much for watching my vlog, no? About reaction rate. Okay, so I'll be giving an example. This is my example. Nakuha ninyo, guys? Okay. So, this is gonna be timan na to that katong mga thermomolecular reaction, molecular reaction. Okay, by molecular reaction, because we need to pattern that our chemical reaction is shown in different types of tests and exams we will be facing in the future. Get the point? Okay, so we have, for example, I have here, so 2 and NO, gas, nitric oxide gas, no? Nitric ba ni siya, guys? Please correct me if I'm wrong. Right? NO. NO gas plaza. Chlorine, chlorine gas. Okay? Is equals to, so this is equivalent as saying A plus B is equals to AB in hypothetical explanation. So this will become NOCl. Now, in rule in chemistry, if you look at the one element or one compound that the subscript is in the here, you will put that to NOCl. You will never put that NOCl to the same as the pattern of what it does. You need to put that here beside the NOCl compound. What is NOCl? This is nitrooxychloride. Okay, this is kung ano siya, chemical. Halide na siya. Okay, halo, di ba? Halide. Di ba? Things like that. So, di ba? Okay, chlorine man Okay, nitrooxychloride. No? Strange kayo guys, no? Kaya tulad yun siya ka-11. Nitrogen, oxygen, and chlorine. Oh my gosh. Okay. So, ano siya itong chemical reaction? Okay. Then put to here so that it will become balanced. The oxygen, balanced na siya. Perfect. Okay. Get the point? Things like that. Bigyan mo agi. Char! Hindi mo agi guys. Diba? 2NO gas plus chlorine gas is equals to 2NOCl. Oh my gosh, really? Yeah. Yes. So, na siya yung mga kuan. So, what rate low is equal to charat. Okay. So, R is equals to the K. Then, it's gonna be NO raised to the power X. Then, chloride gas raised to the power Y. Okay? Things like that. Don't use the coefficient here, right? Because this is not reaction mechanism. Okay, this is initial rate method. So, be careful. Because sometimes you will put the NO and raise to the power 2. That is not applicable here. Okay? Things like that. Any questions so far? So, bye-bye, God bless everybody. See you later. Bye-bye. You can comment down below in the comment section. And you can share this to anybody else, whether your loved ones, neighbors, sons and daughters, friends who take up chemistry classes at present. Or you can even drop off messages in my FB Messenger. Then you can suggest or recommend any topic that you wish me to discuss. Then I will be ecstatic. Happy to do that for you. Thank you so much, and I hope that everybody will be happy and stay happy. Remember that Jesus loves us. Bye bye.